So we're actually going to jump around a little bit because today we're going to be out of section 4.5 in your textbook. Wednesday we'll be out of section 6.2. Thursday we'll be out of 6.3, and Friday we'll be out of 6.4. So we're kind of jumping around a little bit here, but a quick hitting unit. Okay? So simplifying radicals here today is our goal. And again, we're going to focus in on the square roots today, and then we'll bring in variables and other roots on Wednesday. Okay? So let's first talk about the parts of a radical so that we are all speaking the same thing. Okay? So first off, a radical is this symbol. Okay? So this symbol here is a radical. Okay? Oops, get off of there. Okay, so that symbol there is a radical. Okay, if you have this extra curly Q thing down here, that's up to you. Most people just do the kind of check and then flatten it out. Okay, so that's the radical. Now, if you see a radical, then we've got to think radical rules. The first thing you got to think about when you see a radical is you got to look at that blue box. And if there's a number there in place of that blue box, then that is what is called the index. Okay? If there isn't a number there, the index is world-renowned to be a 2. So you're taking the square root. If it was a 3, you would take the cube root. If it was a 4, you'd take the 4th root. If it was an 18, you'd take the 18th root. Okay? So that is the radical and the index. Okay? The index is the big part out there. The inside part of the radical is called the radicand. Okay? And the radicand is anything that is inside of the radical. It's what needs to be simplified, or it's what should be simplified. Okay? So if there's a perfect index factor inside the radical, that is going to need to come out. Okay? And we'll simplify today, and we'll simplify on Wednesday, and we'll simplify all of our radicals from now on. Okay? So outside is called the radical, inside is called the radicand, and we have certain rules about our radicand. Okay? So here are 3 rules of our radicand that we need to remember from prior mathematics classes. I put prior algebra classes, but then I was thinking to myself, you also did some simplifying in geometry. Okay? So rule number 1 is there are no perfect square factors or perfect index factors after we get to Wednesday in the radicand. If there are still some perfect factors in the radicand, then we haven't simplified or we haven't gone far enough, and we need to go further. Okay? Rule number 2. No radicals in the denominator. Okay? No radicals in the denominator. Don't like them. Never have, never will. Okay? When you get into higher and higher and higher math, then they ease up on that rule a little bit more. But for right now, none. Okay? Don't like them. Rule number 3, no fractions in the radicand. Okay? So no fractions in the radicand, no radicals downstairs in the basement, and no perfect factors inside the radicand. Meet those 3 conditions, and life is good. Okay? So let's dive into a couple of other properties. These are more properties than they are rules of radicals. And these properties also work if we have an index. So if I had an index here of some number, I could also break that up and that index would come along for the ride. Okay. So if I'm multiplying two things in the Radican, I can divide that up and I can take the square root or the cube root or the fourth root or whatever of the individual products. Okay? So I can go a times b is this, or the square root of a times b is the square root of a times the square root of b. Okay? And we're going to use that one a lot. Okay? Because we're going to, that's one way to do simplifying. And we'll get to that here in a minute. This fractional one is in there specifically for the no fractions in the Radicand rule. And again, this also works for any index. If I have a over b, that is going to be the nth root of a over the nth root of b. Okay. Those also work for those two. Okay. Okay, let's get into it then. So, you will find, and I will show you multiple ways of doing this. I really don't care which method you choose. Okay? What I care about is that we all end up at the correct answer. Okay? In this first one, I'll show you at least 3 different ways to do it. Okay? All right? And I'm fine with any of those 3 ways, or a different way that you may like. I'm fine with that. Okay? As long as we all get to the answer that's the same. Okay? All right? So, before we get to simplifying perfect squares, or simplifying square roots, I should say, we should remember back to a couple of weeks ago when I told you what the perfect square numbers were. Okay? And those were, again, and if you don't know these, you should write them down again because we're going to use them a lot. The perfect squares 1 to 20 are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, what did I say 19 was? 321 is, right, what am I on? What was the last one I ended off with? 289. Okay, so that's 17. 18 is 324. I think I skipped 324. No, 324. 19 is 361. And 20 is 400. Okay? So those are, one way of doing that is to look for the biggest number on that list that goes into the Radican that you have, if it's a square root. If it's a cube root, then we'll get to those on Friday. I'll give you the cubes, 1 to 10. Okay? And then I'll give you the, and so on and so forth. Okay? So, one way of doing this is you could see that 16 goes into 48 3 times. Okay? So the square root of 16 becomes 4. 4 times the square root of 3 then is my answer here. Okay? Because we set the 4 free. Now, you may not have seen that 16 went into 48. You may have said, well, I know 4 goes into 48. Okay? So then we could have done 4 times 12 is 48. But 12 is what? What's 12? What times what? 4 times 3. So this becomes the square root of 4 times the square root of 4 times the square root of 3. And then this 4, the square root of 4 becomes 2. This square root of 4 becomes 2. And then that's times the square root of 3. Well, 2 times 2 is 4, times the square root of 3 is 4 times the square root of 3. Yet another way that some of you might have done something like this is you might have said to yourself, 48 is 2 times 24. And 24 is 2 times 12. And 12 is 2 times 6. And 6 is 2 times 3. And then because we're dealing with square roots, we're looking for pairs of numbers. So here's a pair of 2's. Here's a pair of 2's. So this 2 is, or that pair of 2's becomes my outside 2. This pair of 2's becomes the other outside 2. And this 3 doesn't have a pair, so it stays inside. Got to have a buddy to go outside. Yeah? And either way there, we get 4 times the square root of 3. Okay? What I'd like you to do now is I would like you to simplify the square root of 80. Ideally, you saw that 80 is the square root of 16 times the square root of 5, and the square root of 16 is 4. So here you should have gotten that this is 4 times the square root of 5. Maybe you did it the green method. Maybe you did it the black method. Another method, the purple method, okay, would be, hey, this is 80 is the square root of 8 times the square root of 10. Okay? Not the best way because neither one of those are perfect squares. Okay? But the square root of 8 is 4 times the square root of 2, or square root of 4 times the square root of 2. Okay? And 10 is the square root of 2 times the square root of 5. This 4, or this square root of 4, becomes 2. What about this square root of 2 times square root of 2? What does that become? It becomes 2. Yeah, it's 2. Okay. And then those two are both outside, and the square root of 5 stays, so you get 4 times the square root of 5. Okay. Again, 4 different methods. I don't care which method you choose. I just care that we all get to the same spot. Okay? The rule when you are multiplying radicals is outsides go with other outsides. They're kind of clicky that way. Insides go with other insides. like when you're multiplying fractions, you can simplify first and then multiply, or you can multiply first and then simplify. Same process holds here with radicals. Okay? You can multiply first and then simplify, or simplify then multiply. Doesn't matter to me. Okay? Square root of 10 times the square root of 15. Okay? If I were to simplify first, I would go the square root of 10 is the square root of 2 times the square root of 5. Neither one's a perfect square, but the square root of 15 is the square root of 5 times the square root of 3. These two then combine to be 5. And so my answer here then becomes 5 times the square root of 6. If you multiply them together first, you would have gotten the square root of 150. 10 times 15 is 150. And then you would have said, well, hopefully you would have said 150 is the square root of 25 times the square root of 6. 25, square root of 25 is 5. Square root of 6 is the square root of 6. So you get 5 times the square root of 6. Okay? I'd like you to simplify number 4. So we've got 3 times the square root of 5 times 2 times the square root of 20, which the square root of 20 is the square root of 4 times the square root of 5. So these two combine to give me 5. This one gives me 2. This one is 2, so it stays 2. And this one is 3, so it stays 3. 3 times 2 is 6, times 2 is 12, times 5 is 60. So I get 60 here for an answer with no radical. If I would have just straight up multiplied outsides with outsides, that would have given me 6 times the square root of 100. The square root of 100 is 10, so this would have been 6 times 10, which then gives me 60. Again, either way, don't care as long as we get to 60. No radicals in the denominator. The key here is we have to multiply by something that is equivalent to 1. Because if I multiply by something other than 1, I change my fraction, which changes my problem, which doesn't give me the right answer. So I can multiply 9 times 1 is still 9. 82 times 1 is still 82. And I have to multiply by 1. Now, 1 will come in different forms. Okay? For instance, in this first one, 1 is going to look like the square root of 6 over the square root of 6. The square root of 6 divided by the square root of 6 is 1. As long as the top is equal to the bottom, that's going to be 1. Okay? And then for this one, on top now, I get 2 times the square root of 6. On the bottom, I get the square root of 36, which is 6. Now I look at that fraction and I say outsides can be simplified because both the 2 from the top and the 6 from the bottom can be divided by 2. So my final answer here is the square root of 6 over 3. because we're dealing with fractions, we still have to reduce our fraction all the way through. Okay? What I'd like you to do now is I'd like you to do number 6. Most of you, I'm guessing, chose the square root of 12 over the square root of 12. Okay? And that's fine. Is there another option here? There is. If I multiply by the square root of 3 over the square root of 3, still equal to 1, correct? So it's still legal. Okay. On top, I get 7 times the square root of 3. What do I get on the bottom? What do I get on the bottom? What? What's the square root of 36? 6. Okay. Like I said, 1 is going to look a couple of different ways. Now, let me show you the way that most of you did it. Okay? So you started with 7 over the square root of 12, and you multiplied by the square root of 12 over the square root of 12. Great. Okay? And that gives me 7 times the square root of 12 over 12. Yes? But what about the square root of 12? Can it be simplified? Yeah, because it's 4 times 3. So this becomes 7 times the square root of 4 times the square root of 3 all over 12. The square root of 4 is 2, and 2 can be divided into 12 6 times, therefore giving me 7 square roots of 3 over 6. Okay. No fractions in the radical, right? Okay? Or in the radicand, I should say. So, first off, the square root of 9/8, this would become the square root of 9 over the square root of 8. Okay? So, the square root of 9 is 3. I can leave it as the square root of 8 now, or I could simplify it to the square root of 4 times the square root of 2, which is 2 times the square root of 2. Either way, then I'm going to multiply by the square root of 2 over the square root of 2, or the square root of 8 over the square root of 8. Okay? And that gives me 3 square roots of 2 all over the square root of 16 here on the bottom, which becomes 4. Okay. You try number 8. On top, I get the square root of 70 because it has no perfect square factors in it. And the bottom, I get 10. Yes? Yeah. The downfall is we might be adding or subtracting radicals in our denominator. And one of our 3 rules was no radicals in the denominator. So in order to clear a binomial that includes a radical, binomial has two terms, remember, okay? So to clear a binomial that has a radical, we're going to use something called a conjugate. Okay? And a conjugate is I keep the terms the same of my binomial. What I do, though, is I go to the opposite operation. So, if my binomial terms were 7 plus the square root of 2, the conjugate would be 7 minus the square root of 2. Those two are conjugates. Okay? Same terms, just switch the sign that's in between them. Okay? So here in number 9, 2 minus the square root of 3 is my denominator. I need to multiply by 1, so I'm going to have the conjugate here is 2 plus the square root of 3. Same terms, switch the sign. My fraction now has to be equal to 1, so that's going to be 2 plus the square root of 3 over 2 plus the square root of 3. Now, one thing that might help you when you're dealing with these is if you think about them in terms of everything is in a set of parentheses. Okay? Because you're going to have to do some distributing going on here now. Okay? So my top distribution is 4 times 2, which is 8, plus 4 times the square root of 3, which is 4 times the square root of 3. The bottom becomes 2 times 2, which is 4, 2 times positive square roots of 3, which is plus 2 square roots of 3, negative square root of 3 times 2, which is negative 2 square roots of 3, and negative square root of 3 times positive square root of 3, which is negative square root of 9. Now, negative square root of 9 really is just 3, because the square root of 9 is 3. The other nice thing about conjugates is these two terms right here cancel each other out. Positive 2 square roots of 3 minus 2 square roots of 3 makes those two terms just go away. So I'm left with, on the bottom, 4 minus 3, which is 1. So this simplifies to just be 8 plus 4 times the square root of 3 over 1, but we don't ever write over 1 in terms of fractions. Okay? What I'd like you to do now is I'd like you to do number 10. What is the conjugate in number 10 of the denominator? 2 minus the square root of 6. So I'm going to multiply the top by 2 minus the square root of 6 over 2 minus the square root of 6. Okay? And again, I'm going to think about this all in terms of everything's in a parentheses. Top becomes 2 square roots of 3 minus the square root of 18. Bottom becomes 4 minus 2 square roots of 6 plus 2 square roots of 6 minus the square root of 36. Square root of 36 is 6. These two terms cancel each other out. The square root of 18 becomes 3 times the square root of 2, because it's the square root of 9 times the square root of 2. So it's 3 times the square root of 2. So there are many possible answers here. The first one is 2 times the square root of 3 minus 3 times the square root of 2 all over negative 2. I would accept that as an answer. Knowing your number skills or your number logic, that could also be, I could take this negative from the denominator and I could put it out front. Or I could take that negative sign and I could put it on top. In all three cases, I am not allowed to combine the top, the numerator, because they are not the same radicants. If I'm going to combine by addition or subtraction any radicals, they have to be the same radicants. The insides have to be the same. And then I just treat that like a variable, and then I can add or subtract the coefficients. Okay? Your homework this evening is out of section 4.5. Oops, tap the brakes. This should have changed. Change this, change this, change this. Tap, tapping, tapping. Tap those brakes, because we changed it to 3 to 18. All like that better. Like that better. And this will be due next week.